The vector triangle. Yeah. So this stuff with vectors isn't that difficult. So how did you find out about that calculator program?
Okay,
like, did someone show it to you before?
No, okay, during IGs,
yeah,
when I used to study math, I used to do this online, like study online.
And
on YouTube, they'd always have like this calculator on the side.
Nice.
I got sick of looking for a calculator, so I was like, let's just download it.
Nice. That's great. Yeah, no, I've seen people use that before. I never know where they got it from. Okay, if you can write this down. So we're looking at now the vector triangle. Whoops. Okay. This might be something you've heard before. The vector triangle is something you've heard before. Yeah. So let's have a look. Okay. Right. So vectors can be added together by using what we call a vector triangle. So if we have two vectors, let's call them A and B. To add the vectors, which we call the resultant vector, or you can do it as follows. So I'll explain with the picture here. We have two vectors, A and B. So let's imagine this one is A and this one is B. Or maybe like here's A and here's B. What you do is you take the B vector, its tail, and you move it and put its tail at the head of the A vector. So the tail of the B is at the head of the A. And to add A and B together, you just draw from the tail of A to the head of B. And that's the result. So this answer is A plus B. We call this the resultant vector. Now, the reason it's called resultant, it sounds like the word result. Do you know this word in English, result? Result means what?
Answer.
Answer, basically, yeah. So this is like the answer for A plus B. This is called the vector triangle. You've seen this before, I'm sure. But maybe you didn't know the vocabulary resultant. So can you draw this and, importantly, make note of this word? This is called the resultant. Okay, so if you could just draw this, please, that'd be great. You don't need to write all of this down. It's really this that's important here. Okay, you drew this? We have this? Yeah? Let's continue then. Okay, so that is, to add two vectors, you put the tail of one at the head of the other. Also, we can multiply a vector by a scalar. So for example, when you multiply a vector by a number like 2, what do you think happens? I'm sure someone knows this. If you multiply a vector by the number 2, stretch 2 times bigger. So it'll double its length. And if you multiply by a half, it'll half its length. And if you multiply by -1, you flip it around 180. So,
Flip it around.
yeah, I'll draw them as an example. So, for example, if this is vector A, then this vector here will be 2A, and this vector here will be a half A, and then this vector here will be minus A. It just gets turned around. Okay, so you can make some small note if you need to about that, if you didn't know that. So, of course, we can multiply, of course, we can add, subtract, multiply, and divide scalars. You know, 2 plus 2, 2 multiply 2. That's easy. Like always. We can multiply a vector by a scalar, like how I showed you here. We can add or subtract vectors using the vector triangle. We cannot multiply two vectors. Well, we kind of can, but that's something we'll do in math class. But we definitely can never divide vectors. So you can never do vector A divide vector B. This is definitely impossible. Okay. So for physics class, this class, we won't multiply or divide vectors. We'll only add them or subtract them. Okay. So you might want to make a note of what you might call these basic rules. We can plus, minus, multiply, divide scalars. We can multiply vectors by scalars, and we can add vectors.
You can't multiply vectors?
You can't do vector multiply vector or vector divide vector. We won't do that in this class. Okay. I think we might have a look at some examples now. Continue. So we cannot multiply vectors or divide vectors. Okay. Right, so this one here, well, I think what we'll do is I'll just have you write the question down, and then I'll do the answer on the board, okay? So here I give you two vectors. A is 5 kilometers east, and B is 5 kilometers per hour north. And then here are the questions for them. So I'll do these questions. I would like you to write them down. You can leave a little space for the answer if you want. Their answers are quite short. So if you can write these questions down. Is that someone trying to come in? Or is that your key? No. Oh, that's what it is. Ah, yes, okay. A zipper? Oh, okay. Cold this morning, yeah?
Yeah.
6.
But it was very windy.
It was the wind that made it feel really cold.
Yeah, 24 miles per hour.
But I think people stayed in bed longer this morning because the traffic wasn't too bad. Did you notice? No.
We didn't stay in bed.
No, I know you didn't. We have maths after this class as well, don't we?
Yeah.
Yeah. And then what do you have after lunch? Is it a busy day?
EAP, WAP.
That's okay. And then go home?
Yeah.
That's okay. Alright, are we ready to see the answers here? Not yet? Okay. If you finished writing them down and you want to try and answer them, you can. I'm going to do them now in a minute. I'm sure you can definitely do the first part, which is to draw them.
Can we go a 5 kilometer per hour?
Yeah, it's funny, but you just draw it as 5 kilometers, because you can't draw the time,
Yeah.
you know. Okay, let's have a look now. Nader, you have these? Yeah, okay. So, the first one, A is 5 kilometers east, and B is 5 kilometers per hour north. So we should have something like this. Okay. Now, part B. Let's see what you think. Can we add these two vectors together?
No.
Why not?
One is a scalar, one is a vector. We can?
We can.
No, you were right, we can't add them together, but your reason is wrong, because they're both vectors.
One of them has time, they don't have the same unit.
Yeah.
They don't have the same unit is the reason, because this one
Yeah.
its length is 5 kilometers, but this one its length is 5 kilometers per hour.
Yeah.
So because the units are different, A and B are different in units. So the answer is no. Fair enough. Yeah. C. T is 2 hours. What's the dimension of TB? So I want to know not what is TB, just what's its dimension. So T is 2 hours. B, remember we said, is 5 kilometers per hour north. So the dimension of TB, that will be the dimension of T multiplied dimension of B. What's the dimension of T? Yeah, what's the dimension? Time, yeah. So the dimension is time. And what's the dimension of B? Yeah, length per time. Or in other words, the dimension of TB should be length. So I didn't ask you what TB is, I want to know what's the dimension of TB. And when you when you really think about it, that makes perfect sense, because B is kilometers per hour, T is hours, so it's like saying, this for 2 hours will make a length. Anyways, the answer is length. Part D is to draw TB. Okay. So TB, what's the T? It's 2, so it's 2B. So the answer will just be a vector which is twice as long. That's all. E, the resultant of A and TB. Okay, so this is TB, and what was A? It was 5 kilometers east. So if I try and add these together, I need to put the head, the tail here with the head here. So if I draw it over here, there's the A. So the result, that's the answer there for part E. And then finally, F. What does it represent? So does anyone want to try and give me the meaning of what the or represents? And I'll help you a little bit. The dimension of A is length, and then this in total, is length as well, TB, and the T was time, and the B was length per time. So do you think you have an interpretation of what the or represents?
The final position.
Final after what?
After 2 hours.
Yeah, doing what? Give me the story, like.
You walked for 2 hours at the speed of 5 kilometers per hour.
Yes. You're missing something in the story, though. That explains this part.
Yeah.
But what about this part?
Walked for 10 kilometers.
No?
First
East.
walk for 5 kilometers east.
No? There's no walking at the beginning because this has no time. It's just the length.
Diverted for 5
No, they're too fancy. No. I'll tell you. What happens is he begins his journey at A, which is 5 kilometers to the north, and then he walks for 2 hours to the east, and he finishes here. So the interpretation is starts at A, so he starts 5 kilometers in the north, and then walks east at 5 kilometers per hour for 2 hours. This is the interpretation. You don't really need to know that. I just wanted you to, I suppose, understand that vectors, they tell a story. They represent something. So this is maybe a little, no, you might get this on the exam. It's a little technical, but you wouldn't get anything more difficult than this for sure in the exam. Okay? So you all understand that if you have something like A by itself, there's no time. So you're just saying that's where it is. It's at A. It's this part here of the story that has the time in it about the movement. Is that okay? I don't know if you're confused or not. The point I'm really trying to make here is that by looking at the units, you can know the story. So like this one here, it has no time. So it means it's at a position. This one here has a time, which means it moved for that time. Do you understand the point I'm making? Is that the units tell a story. This was my point here. Okay, so if you can write the answers down if you didn't get them, I don't know, do you need me to zoom out more? Okay, so once you're ready, we'll go on to the next slide. You wrote this down? Yeah.
So The dimension of TB. What was it?
The small t is time, the b is length per time.
Oh, okay.
Yeah, and then TB together is length. Okay, continue. Yeah. Right, here's another one. Again, I'd like you to write the question down. Oh yeah, was there a shine on it? Now, do you know how to put these down? Do you see at the very bottom there's like a little gap in the sides? It kind of clicks into it. Yeah. Yeah, that's it, yeah. Now, before you do this one, did I tell you about the structure of the exam? You have section A and section B.
A is short.
A is short and B is long. So actually, this is very similar to an A question. Now I know it looks long, but the only reason it looks long is because I broke it down into many parts to help you do it, because it's the first time you're doing it. But just so you know, this is an example of an exam question for vectors. You don't usually get exam questions for vectors because they're not very difficult, but if you do, it would look something like this. So it's important that you write this one down carefully. And you might even want to write on the top exam style question.
How much is a step in meters?
Yeah, what's the SI unit for a step, is it? There isn't one. So you take it as a unit. So it's almost like step is a unit, like meter. So instead of having meters per second, it would be steps per second. Yeah. You wrote this all down? Yeah. And you should write at the top exam style question. Okay, are we nearly ready to see it?
Yeah.
No, I really don't like this. You need to write it down. Write faster, faster. Yeah. You can copy it from a neighbour if you need to. Okay, let's have a look now. So the first thing is a man walks 5 steps north, 5 steps west, 1 step east, and 1 step south. So I should draw that first, okay? So let me just make a sort of graph. I'll do it in green. So I'll just I'm just making a nice sort of table. So each box can represent 1 step in length. Right, so the beginning of the story, we'll put the man here. So what does he do first?
5 steps to the north.
5 steps to the north. So the first, I'm actually kind of doing like a later part, but anyways, he walks how many steps? 5 steps, is it?
Yeah.
So 1, 2, 3, 4, 5, and then next 2 steps.
5 steps west.
5 steps west. 1, 2, 3, 4, 5.
1 step east.
1 step east.
And 1 step north.
Or south maybe.
South.
Yeah. 1 step south. So he finishes here and he starts here. Okay, so the first question is, what was his speed for the journey? Alright, so part A. What's the formula for speed? Distance over time. Now the time is 9 seconds. What's the distance? 5, 5, 1, 1. So 12. So 12 steps. That's the distance. So that would be 1.33, isn't it? Yeah.
Yeah, about
Steps per second. Okay, you have this? You wrote this down, right? Okay. B. Draw the 4 velocity vectors. So the first velocity vector is he's traveling this way. The second velocity vector is this one. The third one is that one, and the fourth one is that one. So that's part B. Part C is draw the 4 displacement vectors. Now, be careful with that one. I'll do that one in green. Part C. No, I shouldn't do it in green. I should do it in black. The 4 displacement vectors, the 4 position vectors. So first position is he makes it to here. That's the first one. Second position vector is to here. You see what I mean? The third displacement vector is to here. And then the last one is he's displaced to here. So these are the 4 displacement vectors. So I want you to understand that displacement is like an arrow that points to where something is. So if something was moving, the displacement vector just points to where it is. Do you understand what I'm saying? Yeah. Whereas velocity vector, where is that pointing?
Towards the direction.
Yeah, where it's moving. Where it's moving. So if we have something moving like this, the velocity is pointing this way, but the displacement is pointing where it is.
Displacement is pointing
to its location.
So it's straight.
Huh?
Is it like straight?
Oh yeah, but I mean it's changing over time. So like for example, if we have a man and he's walking to the east, this will be his velocity vector. So when he's here, his velocity vector is still the same, heading to the east. But let's call this, maybe this is someone here. The displacement points to where he is. So that one, of course, changes because every second he's somewhere else. So this is displacement, and this one here is the velocity one. Okay? Velocity vector, displacement vector. You can see the difference, right? Yep. So that's part C. Okay, now A, B, C, D now. What is the magnitude and direction of his final displacement vector? Well, the good news is we drew that. Let me write here, A, B, C, D. Here is the final displacement vector. How big is it horizontally? 1, 2, like I suppose what I'm trying to get you to see, yeah, it's 4 this way and 4 this way. And the little hint I give you is, I gave the answer, yeah. If you have a triangle with side 4 and side 4, the longest side is 5.65, yeah. So if I draw a triangle here, and if this is 4 units and this is 4 units and this one here is 5.65 units. So the answer is 5.65 steps. And what is the direction? Where is this pointing?
Northeast.
Try again?
East, north,
Northwest. So that's the answer. It's northwest, 5.65 steps. Okay, and then the final one is what is his average velocity?
5.65 steps over 9 seconds.
Yeah, that's it. Now, can you see how that's different to speed? Because with the velocity, you care about the displacement, not the distance. So the difference here for velocity, it's it's displacement over time. And the displacement is 5.65 steps northwest, and the time is 9 seconds. So the answer will be
0.628.
You have it there?
Yeah.
Thank you. 0.628 steps per second northwest. Make sure you have the direction because it's a vector, and that's the answer. So not super easy. You do have to think carefully about this one, but it's a exam type of question for vectors. So please write this one down carefully now if you haven't got it, and then we'll have a look at something else. So in the exam, I was saying that it's a section A question, but this one here has many parts in it. That's because I broke it down to make it simpler. In the exam, it would just simply say, a man, blah, 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 and then the question is, what is average velocity? So they won't ask you this, but can you see that I needed to do this to understand how to do the last part? So in the exam for section A, the question would be, a man, blah, 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 what is his average velocity? you won't have these parts broken down. Yeah.
So basically the steps to calculate the average velocity is A, B, C, D.
Yeah. Now, I probably overkilled it by breaking it down too much, you know, with the diagram here and all that. But I just wanted to make it super clear what was happening. So like, I probably went too far by drawing all the vectors here and everything like that. The key thing is the displacement over the time, but you need to work out the displacement, so you at least need to draw something to work it out. You notice that I didn't need to know the speed actually. You see here, this does not factor into the answer here, but the only reason I did that is to show you the answer is different if they ask for the average speed and the average velocity. You know, you might think it should be the same answer, but you can see the answer is very different. So I was kind of making a point by doing this one.
And do we have to draw this?
You only draw what you need to draw to help you to do it. So here I just drew it.
Okay.
You have all of this?
Yeah.
Yep. Did you draw it?
Yeah.
Let's see your beautiful picture. Beautiful. Have you seen anything like this before with vectors as a question? Yeah? No? Okay. I think I'll go on. You might have to get this from someone. Okay. Right, so we have two vectors A and B, and vector addition is commutative. Does anybody know this word, commutative?
They combine.
No. Nice try though. Commutative. We know that they already combine because, yeah, I said it earlier. What does commutative mean? It's something about how they combine. So commutative means in maths, it means that A plus B is the same as B plus A. So if you have vector A plus vector B, that's the same as vector B plus vector A. That's not really surprising. And that's the only point I wanted to make at the end there. So it doesn't matter, the order doesn't matter for how you add vectors. So you can, I think it's good to write this word down because it's a new word, commutative. A plus B equals B plus A. Okay, got that? Yep. Okay. Right, so let's see how we're doing for time now. Let me think what the next lesson is. Yeah, I think I'll give you a few minutes to do these because I don't think it will take you too long to do these. I'd say it'll only take you about 5-10 minutes maximum because the first one is just to draw again, and part 2 is like the example I gave you, and part 3 is also like the example I gave you with the man walking north, west, east and south. So I think about 5-10 minutes maximum. Yeah.
Without writing the questions.
No, because this is on Moodle, so you don't have to write the questions down. Can I close this? I can close this?
Yeah.
Yeah.